I'm Lucy Gunawan, Head of Data Science at TIMI. Today, we're going to dive into loops and parameterized graph within Anatella. We'll cover two main areas today. First, what are loops and their practical uses in Anatella. Second, how to set up loops in Anatella. Let's start with loops and their practical uses. Loops in Anatella allow you to repeat a sequence of steps for a set of data. This is particularly useful for tasks such as processing multiple files, iterating over datasets, or performing repetitive operations efficiently. Some practical examples of using loop. First, processing multiple files. Iterate over a directory of files, processing each file in turn. For example, you have a directory full of CSV files and you need to process each file to extract specific information. Second, batch data processing. Apply the same set of transformation to multiple datasets. For example, you need to apply the same data transformation to a multiple datasets, such as adding calculation and uniformize the data in each file and then combining the result. Third, performing repetitive operation efficiently. Converting from one format file to another format file. For example, you have a directory of text files and you need to convert each file to an Excel format. Now that we know what loops are and their practical uses, let's set up loops in Anatella to see how it works. Loop can be one of the trickiest operations in Anatella, but don't worry, they are manageable without any need for coding. There are two types of loops in Anatella. First, for loop. Use the Loop Anatella Graph Advanced toolbox. This loop iterates for a number of iterations defined in the input table. Second, while loop. Use the while loop Anatella graph box. This loop iterates until a specific error level is fired. To make this clearer, let's look at an example use case of for loops in Anatella. Basically, the objective is that we want to read multiple CSV files, apply some data transformations, and save the transformed data to combine all data in an Excel format. To create a loop inside Anatella, you need at least two graphs, thus two .anatella files. The graphs are named control graph and subgraph. First, the control graph manages the loop, defining both the number of iterations and how many subgraphs are executed simultaneously in parallel. The number of loop iterations is equal to the number of rows in the input table. The control graphs also send data to the subgraph. For example, the control graph will send an iteration counter to the subgraph. The data from the control graph will appear inside the subgraph as global parameters. The second graph required to run a loop is the subgraph, also known as the inner graph. This graph defines the action to be executed as part of the loop. It will be executed for each iteration defined in the control graph. Let's take a closer look at this process. We have a collection of CSV files stored in the folder C Data Lake Europe Survey Data. In this example, there are 10 CSV files, each containing survey data. The file names are based on the researcher who submitted the data and the exact time the survey was sent. This information is embedded in the file name rather than within the content of the file itself. For example, this CSV file indicates that the file was produced by researcher A and sent on the 22nd of July 2023 at 10:30. Our task is to process the CSV files to extract the timestamp in a more readable format, for example, like this, and retrieve the researcher's name. Once we've gathered all the data, the next step is to combine the content of all CSV files into one single Excel file named Europe Survey Result. This Excel file will contain one consolidated table in a sheet named Raw Data, while we'll store all survey data from the CSV file. Additionally, we'll create a summary table on separate Summary tab. This summary will display the number of surveys submitted by each researcher and the average satisfaction level per respondent. Let's demonstrate this in Anatella. As you might have guessed, we need to make an Anatella subgraph that will run 10 times to get all the data. First, let's create an Anatella subgraph. This will help us define the action to perform at each iteration of the loop when processing the file. Right-click on the File Explorer window and choose New Anatella Transformation Graph. Then name it Survey InnerLoop.Anatella. Double-click to open this file and import one of the CSV files. Let's start with the first one to preview our data. Next, we need to extract the researcher's name and timestamp from each file name. To do this, we want the file names visible within our data preview. Click on the Advanced parameter in the Read CSV box and select Output File Names as an additional column. This option will include the file names in our data, making it easy to parse out the researcher name and timestamp. Let's extract the researcher name from the column File Names, add the calculator box, and add file names as an input variable. Uncheck the two-number checkbox. Create a new variable researcher and change the meta type to string. The researcher's name is the text between the last /+1 and the first underscore. Thus, take a substring from the file names from the last index of / till the first underscore. The syntax is... Let's check if it works. Yes, we have the name of the researcher. Now, let's get the timestamp. Add a new variable timestamp and change the meta type to string. Extract the timestamp similarly. The syntax is... To make the timestamp more readable, let's use the DateTime formatter box. Leave the operating mode as Update column. Choose the column containing the data to reformat, then set the old DateTime format to this format, and then the new format to this format. Let's check it. We have now the timestamp in the data. Now we have all the data we need, and we are going to save this to a new CSV file with additional data. Add a Write CSV box. For optimal speed and reliability, it's usually best to save intermediate dataset as .gel files, as this format is significantly faster than other file formats. However, for the sake of this example, we'll save our intermediate data as CSV files. But before we continue, to make the subgraph dynamic based on parameter, we have to create two global parameters, the input file name and the output file name. Let's now make this. Create two global parameters, my input file with the value and my output file with the value. Here, data lake is simply a term for the directory that holds all our dataset files. To prevent any potential conflict with column names in the input data files, I like to add my prefix to the names of the global parameters I create. For example, my cutoff date, my file name. Of course, this is just a preference, and you're free to use a different naming convention if you prefer. Now, we need to change the file name in the read CSV box with the parameter magic character and the output file name in the write CSV with magic character. As we don't have the folder yet at this point, ensure the create output directory if does not exist option is checked. In order to be used in the loop, we must have a finish line in the subgraph. Let's check if it's working. Yes, we have the process CSV file in the folder. Now that we've created the subgraph for use within the loop, let's create the control graph. In the File Explorer, navigate to the Survey folder. Right-click on the empty space, select New Anatella Transformation Graph and name it Survey Control.Anatella. Double-click to open this new graph in Anatella. The first task in this control graph is to list the files we want to process. Locate the List File To box by searching for it or finding it under Transformation, System Tool, and List File To. Set the filter to *.csv and in the directory to list field, browse to the Europe Survey Data folder. Let's run this and confirm that it correctly lists all 10 CSV files. Success! Next, we need to tell which subgraph to run. Add the calculator box, make a new variable called graph. Change the meta type to string and fill it with the constant survey inner loop.anatella. Remember, we have two input parameters for the subgraph: the input file to process, name my input file, and the output process CSV file, name my output file. We already have a column with all the input CSV files, but it's currently named incorrectly. Let's rename this column to my input file to match our subgraph parameter. Next, we need to define the output parameter, which we don't have yet. To do this, inside the calculator, create a new variable called output. Change its meta type to string and set it with the following expression. This expression specifies that the output file will be stored in a process folder within the defined directory. It's quite a transformation. If you need a refresher on string manipulation, don't hesitate to check this video. Calculator box string manipulation. So, let's check if it's correct. Yes, it is. Now, add the Loop Anatella Graph Advanced 2 box to the graph. In the Anatella Graph 2 run inside the loop, choose Graph. Then in Global Loop Params, put both the columns my input file and my output file. Then let's add the finish line. Now, let's see if it's running properly. Let's open the File Explorer and run it. You can see that all the process CSV files are there. Note that it takes 15.93 seconds to finish processing the 10 files. If you want, you can also run the same loop in parallel on multiple CPUs. Change the Run and Graphs in Parallel option to, for example, 3 and uncheck the silent mode. This way, you can see how it runs in parallel. You can see that it's faster this way, only 1.57 seconds instead of 15.93 seconds when we don't run it in parallel. Now, the second assignment is to put all data in one Excel file within a single table inside the raw data Excel sheet. Let's do that. Extend the Run to Finish line box to have more pins. Then, from the Input Box category, put the Read CSV box into the graph. I will show you how you can combine all the CSV file only with this box. Put the process folder and *.csv in there. Ta-da! You have all the files in one table. You might ask why we needed to use the loop before instead of loading everything directly. Well, I just wanted to show you how the loop works and how sometimes in a Natella you don't need to use the loop for something like this. Okay, let's continue with our assignment. Add a right Excel box to the canvas and in the file name destination, put Europe survey result.xl and the sheet name as raw data. Let's run it. Let's open the destination file. Yes, we have all 10 survey responses with the researcher and timestamp. The assignment also specified that we should aggregate the data on the Summary tab. This tab should include a table showing the number of surveys submitted by each researcher and the average satisfaction level per respondent. Add the aggregate box. Add a group by variable, which is researcher, and then check the counts in the output column. And add as output column satisfaction level and click the mean. Let's check the result. Now, copy the right Excel box and change a few things. Change the mode to update an existing file by adding a new sheet. Leave the file name and change the sheet name to Summary. Let's run it. There we have it, the output Excel file with both raw data and summary. Let's take this a step further and discuss the organization of large projects. Imagine that this small task we just created to process survey data is only a part of a much larger project. To manage and coordinate such a project effectively, we can create a main.anatella file that orchestrates the different tasks of this large project. Typically, this main.anatella file will look something like this. The first step of this main.anatella file is to use the get parameters from file box to define a global parameter named myDataLake, which contains the path to the data lake. The second step in the main.anatella file is to sequentially execute each task that makes up this large project. One of these tasks is the survey control.anatella graph that we just created, which processes all the survey data. Currently, the survey control.anatella graph does not use the myDataLake global parameter, so let's make that adjustment and define the global parameter myDataLake as cDataLake. Open the list file toolbox and change the directory to list parameter to magic character myDataLake plus Europe survey data. Open the two right Excel boxes and change the file name destination parameter to magic character myDataLake plus Europe survey result.xl. We've just transformed the survey control.anatella graph into a parameterized dynamic graph. Currently, it has only one parameter, the location of the data lake, but that's already a great start. Now, let's update the global parameter myDataLake inside the config.cfg file by changing its values to dDataLake instead of cDataLake as previously said. After making this change, delete the output survey result Excel file, run main.anatella graph and observe what happens. This main graph calls the survey control.anatella graph, which in turn creates the results Excel file. However, as you can see, this didn't work as expected. What just happened? Where did the error come from? Let's look at the value of the myDataLake global parameter within the main graph. Here, it appears correct. It changed to dDataLake as expected. However, this change did not propagate into the subgraph. For example, inside survey innerloop.anatella, the myDataLake global parameter remained unchanged. You can see this by executing the main graph and checking the trace in the Anatella log window. A simple fix to allow the updated value of myDataLake global parameter to propagate to the subgraphs is to add it here inside the specific parameter of the loopbox. This explicitly send the global parameter in each subgraph where it's needed, keeping everything in sync. Let's run the main graph again. This time, as expected, the results Excel file is saved in the D drive. Yes! Another way to fix this issue would be to add a get parameters from filebox as the very first step in the survey control.anatella graph, like this. Personally, I find both solutions equally effective. The first solution is slightly faster. However, the second solution is generally much easier to set up for large projects. You simply place a get parameter from filebox in each graph that needs to know the data lake location. And that's it. With this approach, you have a single centralized config file where you can manage the values of all critical global parameters, ensuring consistency across all Anatella graph within your project. You should know that there is a third way to fix this issue. You can also use the global loop params option inside the loop box in conjunction with the calculator box. We won't discuss it here since it's not very relevant. And that's it. This finally concludes our loop tutorial. We cover how to create a parameterized graph, execute a loop in Anatella, and ensure consistent value for all essential global parameters across potentially hundreds of different Anatella graph files in a large project. Thank you for joining me in this tutorial. If you have any question or need further clarification on any of the topic covered today, feel free to leave your comment below. We highly value your feedback. And if you found this video helpful, don't hesitate to give it a thumbs up. If you are interested in more tutorial, engaging discussions, and useful tips, please consider subscribing to our channel. See you next time.